A, you should all be working. This is wrong. This is very wrong.
What trail? What happened? Oh, the spaces. We're gonna move a little bit. Seem farther up.
You two, this way 4 inches. Because I thought ahead. Watch out. Okay. That one's supposed to be 4 inches over. It is where it's supposed to be. Make me a polynomial.
I am making you one.
2.54. Yeah.
Just goes, I don't know what an inch is.
Should have said yes. Said it.
Oops.
Yes.
Respect. I can't paint with a damn. It's not neat enough. It does not fit boundaries. It does not do what I want it to. I was always a thin line marker and colored pencil person.
I couldn't even paint.
Here.
Okay. Plenty of time. -2, -2, 4, -5. We're going to do... What was it? -2, -2, 4, -5? Okay. If I know the zeros, then I also know the linear factors. Linear factors are always x what? Specifically x minus the 0. So I know I got one of these because minus a -2 minus a -2. I know I've got minus a 4 minus a -5. Multiply separately first. Cool so far?
Yes.
Okay. Once you've got your quadratics, it's just a matter of multiply those together. So x squared times the stuff. Well, it depends how you want to do this, right? Whatever your method of organization was, I saw a couple of you doing boxes, saw a couple of you like a spaghetti monster drawing arrows everywhere. However you do it. I've always done kind of a distribution stacked, almost like old school multiplication. X to the 4th, x to the 3rd, and minus 20x squared when I distribute x squared. Distribute 4x, 4x to the 3rd, 4x squared, minus 80 honkin' x. 4 times the stuff, 4x squared, 4x minus 80. And finally, I have my function, my polynomial is x to the 4th plus 5x to the 3rds minus 12x squareds minus 76x minus 80. Did you write out all of your binomials correctly? Did you get to the correct quadratics? Did you get to the final form correctly? Then I'm going to leave between how I got my paired quadratics and here, I'm going to leave 2 floating for I did a dumb. Oops. I said negative 80 plus 4 was negative 84. Like the little arithmetic error that just shouldn't have happened. I was just going too fast or didn't catch it. Okay. So 3 on process, 2 on work. Okay. Any questions in there? All right. Then, because I actually thought ahead this time, OMI work. I don't think I had any questions from anyone, but I mean, honestly, if I have any questions, it's usually a back and forth half-hour conversation with Ava because she asks amazing questions. But anyone else? Okay. Wait, no, not that way. This way. That's a different page. There we go. 39, you said? Oh, wait. I'm completely on the wrong page because this is a teacher's edition. There we go. 39. Oh. There we go. Ah, words. Okay, I know it's a little fuzzy, but close enough. The reason I included this, I've actually seen them do this project down in Welding Lab. Like this project, specifically. So, got sheet metal, you got to cut the squares out the corners. What is your length, width, and height of the open box? And it's going to be expressions. So if the whole thing is 16, but I'm cutting x out of this corner and x out of that corner, then when I fold it all up, this is no longer 16. This is 16 minus 2x. This side is no longer 12, x. This is 12 minus 2x. So how tall is it? If I'm cutting x here, then when I fold that flap up, it's going to be x tall. Because x is the size of the square. You know what? Every time Rylan just decides to say random numbers.
That was close. 12 minus 2 is 10. No.
Okay, so I'm going to put x right there. All right, so length, width, and height, there we go. Use the expressions to write a function, so write it as factored form, that times that times that. And then if I wanted to graph it, honestly, I wouldn't even distribute. I would just write that times that times that in y1. And it says find the maximum volume. So when I multiply this out, I'm going to have a positive cubic. Go find your maximum. Okay. That's it. That was kind of what our last problem was that I hope you finished. But this specifically is, I have seen them do that down the welding lab. That's also a good example of how do I maximize volume within a particular amount of materials. What's the most that I can fit in this tank with only this material? What dimensions should I make the tank? Like, now you're starting to get into the actual application of how do I maximize polynomials? How do I use the features of polynomials? Okay, we use it to maximize or minimize an amount. Okay, y'all hear there's a lot of space stuff in the news recently because there's a bunch of rich a-holes that are shooting themselves into space and sadly coming back. They're right now, NASA is working on a replacement for the Voyager. Y'all know what Voyager is? It's a satellite that was supposed to initially be shot out to just Jupiter like 30 years ago. And it was only supposed to last like 3 to 5 years, but it's still going. So they just kept driving it around and seeing what they could take pictures of. And it's going to start crapping out. Well, now they're looking at building a new one. Like, these engineers have to make sure that they can get the most bang for their buck. They got to make sure that they can have the strongest material within a smallest mass, that they can cover the largest area with their reflector panels with the least amount of mass. Like, all of this comes into play later. You're just learning the foundations. Now, you're never going to get there if you can't figure your own way out of a friggin' sweater.
I was trying to get it, my arms were cold. He's got 3 of those. Give him a fun one.
If there's no other questions on the homework besides words, then let's go to solving them. How do I solve a quadratic? Yes, I do thing. What is thing? Okay. All on one side, set it equal to 0. Once it's equal to 0, you can use quadratic formula or complete the square or factor, however you're going to do it. The idea was always I set it equal to 0. Because if I set an equal to 0, well, if A times B equals 0, one of the A and B has got to be 0. That's how we solve, because it's a known quantity about 0. The same thing's going to hold true for larger polynomials. Now, they're going to start baby steps. This is not a quadratic, but it is a polynomial, and the rule says everything on one side. So, start by getting everyone on one side. And then factor. We were already factoring polynomials. What goes first? GCF, greatest common factor. Yep. Now, some of us are going to have the mental math mojo to go directly to, I know that's a 2x and I know that's an x because 2 is prime. The only way I'm making 2 is with 2 and 1. I also know the only way I'm making 3 is with 3 and 1. So some of us will have the mental math juice to just kind of guess and check some 1s and 3s in these spots until you get what's going to distribute for a -5 in the middle. If you can jump straight from there to there, that's fine. I might start writing that. because it's expected. Look, you did Algebra 1. You should have worked with a few quadratics in geometry, but we just beat the living crap out of them for about 3 weeks. You should know how to quadratic. If you can't jump from green to orange, how do I factor something like this? Well, that's if you're going to complete the square. AC method, right? You take what factors of -6 add up to my B term, -5? Okay. So what you got to remember is that there's a x on the outside here. So this is now 2x squared.
-6 what?
-1.
No, it'd be
6 messes with kids.
2 negative.
I'm hearing kids say 6 and 1 and 2 and 3. Which is it?
6 and 1. -6 and 1.
Okay. Oh, I know it's -6 and 1, but then I started hearing a couple of scattered voices around the room be like -2, -3. Well, no, that makes a +6. Something about the number 6 when factoring really messes with kids. Yes, it breaks into -6x plus 1x. Then what? Cut it in half. Say these two have a 2x in common, leaving a x minus 3. These got nothing in common, so I put a 1 as a placeholder. And then, because they have a x minus 3 in common, you take a x minus 3 out, leaving a 2x plus 1. What I want to caution you about is don't forget your kid brother at Burger King. Okay? So whether you have to use the AC method or not, you should be able to get from green to orange. Once I'm there, if I said A times B equals 0, what's got to be true? One of them got to be 0. So what happens if I have A times B times C equals 0? One of them got to be 0. I don't change what I'm doing. I'm saying that this equals 0. So I set each equal to 0 and they become separate equations. If I say 2x plus 1 is 0, then 2x is -1, so x is -1/2. X minus 3 is equal to 0, so x is 3. Set it equal to 0. This is a whole nother factor. So if you're ever able to factor out an x, it's actually really nice because you just know automatically one of your solutions is 0. And that's how you write it. You say x is 0, -1/2, 3. It is all 3 of those. Those are my 3 x-intercepts. But we got to know our factoring mojo here. In fact, that's kind of what today's about, is now that we know how factoring works for quadratics, let's ramp it up and do it for something bigger. Okay. Again, everything to one side of the bus. 3x to the 4th minus 6x to the 3rd plus 12x squared is 0. Take out your GCF. 3x squared, leaving x squared minus 2x plus 4. What factors of positive 4 add up to negative 2? None, which means it's not factorable. But I'm a big kid now. We know how to deal with those now. Quadratic formula or complete the square, I don't care. You do whatever you do, okay? They are perfect squares, but if I tried to do that, x minus 2, the quantity squared, does it FOIL into the same thing? So remember when we went through the perfect square forms and said difference of squares or conjugates? Said those special forms, if A and C are perfect squares 95% of the time, it's a special form. But you have to check your distribution to make sure that it actually is. Sometimes it looks like a duck, it quacks like a duck, it turns out it was a platypus. Okay? So, I personally am a fan of complete the square because for me, I can keep the steps for complete the square straight in my head. It just works for me. Good chunky are coming up to pre-calc. By the time we get done with conics, where you're completing the square twice in a problem, believe me, you're gonna think completing the square is faster than quadratic formula. Okay? It really is. It's just you're not comfortable with it yet. Because in Algebra 1 and Algebra 2, we show you both, and then as we move on from there, we say, I don't care, solve it however you want. And most kids choose the formula. Because formula plug and chug, right? So I'm going to do that. That's my jam. Remember, move the constant over. Add b over 2 squared to both sides. Write it as x minus b over 2, the quantity squared. That's supposed to be a 1. Oh. Oh. That's supposed to be a 1. Hi. Yeah? Ah, crap. Yeah.
Yeah.
Okay. All right, so let me actually write this then. Hold on. X minus 1 is negative 3. I'm trying to go a little too fast there. X minus 1 is plus or minus I root of 3. So x is 1 plus or minus I root of 3. There. Okay. Mine. So, what's the answers? These are two imaginary answers. If I set x squared equal to 0, won't x equal 0? And it'll happen 2 times. Now you don't need the 2 there because it didn't ask for multiplicity. If it helps you, great. If it doesn't, don't do it. So there's actually 4 answers here. X is 0 and 1 plus or minus I root of 3. We are now at the stage where I'm going to give you polynomials, something much bigger than a quadratic. Cubics, quartics, quintics. Maybe we'll head up to degree 6 or 7 sometimes and say, find them all. You just got to find all of the zeros. But the key to it was getting quadratics. That's why we spend so much time on quadratics, because these can be broken down into quadratics. Because I know how to deal with those. Whether you're going to complete the square or quadratic formula, I do not care. Okay? What? What?
I got negative 12 out of those. So how do we get a square root of 3 out of that?
Because 12 is 4 times 3.
So then, where's the 4?
Two, no, 2, 4, 1, 1, 4. 4 minus 16 is negative 12. But isn't negative 12 negative 1 times 4 times 3?
You gotta bring the 4 out. Then you got 2.
So where did you get your...
Yeah, you have 4 plus or minus square root. Wouldn't that be 2?
What?
The 4 plus or minus
In the
square root of 12.
Right. It's a 4.
Then it shouldn't just be 2.
Oh, there we go. Okay. So 2 divided by 2 is 1, plus or minus. This is 2i root of 3. So 2i root of 3 over 2 is I root of 3.
Okay, that makes sense.
Oh, you're confusing me.
Like, no.
You know what? We'll leave it up to fate. There's a brownie point. Odds it's me, evens it's Caden.
What you, sir?
There we go.
It was all even dice.
It's a 20-sided die.
No, wait, what did I do wrong? How did I get it?
Confuse the crap out of me. And then I started screwing up. Do those two, please.
Dude. Where are we at? I just asked for it. I didn't think we'd have to do these.
Wait, where are you?
Yes. Find all solutions. A is going to have 4 of them. B is going to have 5 of them.
I know B is.
They might be repeated.
Wait a second.
They might be real. They might be imaginary.
Couldn't I just like figure out how these split up and then flip the sign?
The square root of 1.
Kind of see what I'm trying to say?
What does that benefit you?
Because like
The square root.
Oh, no. Yeah. I know what you're saying. Okay. That's what I mean, is this is difference of squares. So x plus 1, x minus 1.
So then do
This is sum of squares. So instead of x plus 2, x minus 2, because it's sum of squares, they're i's.
and then
Now, set each equal to 0. Yeah. That's literally one of the two primary ways to do this.
and -1, 1,
What's the
-2
square root of
I,
-4?
and positive 2 I.
Yep.
2 i's.
Okay.
Hmm?
And for this one, you already said equal to 2, so you just move everything to one side.
2i multiplied.
Incorrect. Plus or minus.
So for this one, I think it's set equal to 0.
Yep.
But I'm confused with what to do.
GCF.
Greatest common factor.
Yes.
So I can take x to the third out.
Yes. And that'll make what's left a regular quadratic that you know how to deal with.
So then I deal with x to x squared.
X
But yeah, I gotta complete the square. Because I'm
or quadratic formula, or in this case, factor.
Because I'm taking x to the third out.
Yep.
Okay.
There you go. Make sure it's actually outside. It doesn't just poof into the ether. It's yeah.
Every time
I don't care.
Sweet, thanks.
I think there's a lot more important things that they should be addressing in the school besides that.
Yeah.
This is weird.
However, if there's ever an administrator that walks in, I completely throw you under the bus and say, "Oh, I'm tired. I didn't notice."
So can't you just like plug this in with this formula and just solve it?
Yes, you can.
Okay.
It's overkill. That's like deer hunting with a bazooka. It is overkill, but it will work.
Basically.
Don't you want there to be deer left?
Basically. As long as you shoot it, you don't want all the meat. You shoot it right in the skull. And then you have to worry about
So far. Okay.
And I like the highest count that does it.
Plug and shove, there we go. I don't think so.
I have no idea. We buy it. We got it.
It's not negative. It's positive. Oh wait, yeah. Mine. It's like negative. Yeah.
I mean, okay, I'm glad you said you can't. I can't like.
Oh,
No, I ate this one.
No.
you be a stand-up guy about it. Andrew brought in brownies the next day.
Wait, what? Oh, Andrew did?
Yeah. He even made them himself. They're tasty.
He made his own brownies?
Yeah.
There's no way they can't be tasty. He knows exactly how to make them. Wait, is it 5? Do you buy the ones that are in the book?
Half 5. Yeah.
Okay. Just give him one more day.
Oh no, fair's fair. He's got to earn it.
Don't worry. It's easy to get 2 in one day.
Okay, sounds like we're either there or stuck. Okay, part A, 2 different ways to do it. Option 1. I can factor because this is a difference of squares. We did it recently. How do I handle the sum of squares? It's still square root of this and square root of this. But because it's the sum of squares, what's different? I's. So, x is plus or minus 1 and plus or minus 2i. Ta-da! Okay. Now, option 2.
So how did you do the quadratic? I feel like there was like, wouldn't they put with the full? Okay.
Option 2. Set that equal to 0. Square root. Set this equal to 0. Okay. Those are the 2 simplest ways to do it. Sum and difference of squares by factoring or solve by square roots. Or Dawson wants to go deer hunting with a bazooka. You can say x is negative b plus minus square root of b squared minus 4ac all over 2a. And a is 1, c is 4. There is no b term, so what's b? 0. 0, 0, 1, 1, 4. Getting 0 plus or minus the square root of negative 16 over 2. So that's plus or minus 4i over 2, so that's plus or minus 2i. It works. That's like there's a moth that came in with you because you left the door open too long, so you use your golf club to get it off the wall.
That works.
Yeah. It also works with bats. Well, yeah, but then you get shrapnel. But
Have you had one in your house?
we had a bat get in our house, yeah. Like all the way from the second floor, and I had to like just keep turning on lights and just kind of herding it down the stairs, through the kitchen, through the basement, finally landed on the wall, grab a broom. That's just gonna make it mad. Oh hey, there's my wife's golf clubs. Whack!
I
I don't know.
You just said if it's in your house,
What was funny though is after we moved out, the blood splatter was still up on the cinder blocks.
Oh, that's nice.
It was a rental. So, okay, this one. Take out x to the third. Uh-oh, I see 6 again. How do I factor it? Are you sure this time? Okay. X minus 2, x minus 3. So all I need to write is x equals 0, 2, and 3. I don't need to say that this is multiplicity 3 if all it's asking for is the solutions. If it's asking for the x-intercepts and their multiplicity, okay, then I'm going to put That. You do not need to write that as part of your answer. It's also not even official notation. That's just me being lazy. Okay? Because you set each of these equal to 0. Good? So, all right, folks. You are going to want to have this particular chart here, if not committed to memory, at least like highlighted, big flashing neon sign. This is important because everything up here all the way down to the bottom, okay, everything up here you saw all the way back to Algebra 1. And we just reviewed for the last 3 weeks. Okay? You can factor by GCF. You can factor by AC method. You can factor perfect square trinomials. A and C are perfect squares, right? You can factor the sum or difference of squares, even if they aren't squares themselves. We talked about this, right? You can just leave it as square root of 15. Technically, this is factored. This is correct. It's just not until this year have we seen factoring that resulted in radicals. This you probably haven't seen since Algebra 1. It's what the AC method is built off of. It's called factoring by grouping. When I use the AC method, the entire point of it is I don't want 3 terms because you, your friend, and their significant other makes for an awkward night. But if you bring another friend, well, now they can go do their thing, and you two can at least, I don't know, play Clash of Clans or something. Like you have something in common. They suck. I need 4 terms to factor by grouping. Sometimes you already have 4 terms. These two have a x squared in common. These two have a -3 in common. Look at what they both have now. Take the x plus 2 out, leaving a x squared minus 3. Now I could keep going. Now I can turn this into x plus square root of 3, x minus square root of 3 by using difference of squares from right above it. Okay, but this factoring by grouping thing, we haven't seen it like that for probably a couple years. But do you follow it? Like if I've got 4 or more terms, I can say you guys over here and you over here. And then take out what they have in common. Just like the AC method. The thing that's brand spanking new is the sum and difference of cubes. That is super important because this is how we're going to get our imaginary zeros. So what I mean is, right now, if I was to give you that and say solve, just solve.
Easy.
What is it? No, it's not. What does x equal? How'd you get that? Okay. And if I undo squared with square root, I can undo cubed with cube root, right? So what cubed makes 8? 2. Congratulations, you got 1 out of 3 answers. I want you to graph it. Y'all got a graphing calculator. Say y equals x cubed minus 8. And I want you to see where it crosses the x-axis. Type y is x cubed minus 8 and find where it crosses the x-axis. Find its zeros. This thing has 2 imaginary zeros with it. And you are not going to get imaginary zeros by looking at a graph. You aren't going to get imaginary zeros by just solving by cube roots. You have to know the sum and difference of cubes factored form. Now, in past years when I've gone through the proof of where this comes from, no one cares. Just, it's magic, believe it, Muggle. Okay? It works. You need to write these down. The idea is, in this, I identify what got cubed. X got cubed to make x cubed. 2 got cubed to make 8. Cool? Like cube root of x cubed is just x. Cube root of 8 is 2. So that is my A and my B. So this becomes x minus 2 times, okay, take the x part and square it. Take your A times your B, so x times 2, and your B squared. This is how it factors. Do you see now how I got my imaginary zeros? If I set this equal to 0, yeah, I'm going to get x equals 2. But what factors a positive 4 add up to 2? They don't. So since this is not factorable, I need to go to quadratic formula or complete the square. And when I do, I get 2 imaginary roots. So you have to know the sum and difference of cubes formulas, or be very cognizant of where it is in your notes, because we're going to keep coming back to it for the next 2.5 months. Okay? And for all of you coming up to pre-calc or doing college algebra, it's just assumed walking into the class you know that. Okay? So let's get it in practice. There's a proof for it. Just say, I believe in math. And let's move on. Okay? Real or imaginaries, I'm going to start with B since it's what we were just talking about. Step 1, everyone to one side of the bus. And I recognize it's a difference of cubes. So the first thing I'll do is identify what A and B are. So I'll say my A, what got cubed to make x cubed? Oh, x. What got cubed to make 1? 1, right? Cube root of x cubed, cube root of 1. If I know that, now I'm going to plug into this form A minus B, A squared plus AB plus B squared. Okay? What? No. because the form is a minus b. Literally this. That's what's on your page. It's of the form a cubed minus b cubed. The signs are taken care of in the form. Okay? So now I'm going to plug x and 1 in everywhere I see a and a b. X minus 1. X gets squared. X times 1. 1 squared. If you do this correctly, you should have a linear factor that you can just set equal to 0 and solve. That gets you your real 0. And you should have an irreducible quadratic that can't be factored and results in imaginary zeros. Because what factors of positive 1 add up to 1? Doesn't happen. So your choice, quadratic formula or complete the square?
Formula.
Okay. I'm going to plug in there 1, 1, 1, 1, 1.
Oh,
Right? A, B, and C were all 1s.
So it's 1.
No.
I said it if you could tell you read my voice.
Here I'll have 1 squared is 1 minus 4 is the square root of a negative 3 all over 2. Separate your real friends from your imaginary friends. X is negative 1/2 plus or minus square root of 3 over 2 I. Right? Squared negative number is I. We done forgot our little kid brother at Burger King again. That's the solution for the quadratic part. Set this equal to 0. You have to have all your answers there. There you go.
You just did it.
Okay. So you have 3 solutions. 1 and negative 1/2 plus or minus square root of 3 over 2I. But I'm not going to find those if I don't use this form. Maybe a note to yourself. The sign matters. Because look at the 2 different forms of sum of cubes versus difference of cubes. Look at the 2 formulas. They change the signs slightly. Okay? There's another way to factor called quadratic form. It's not actually a quadratic, but it looks like a quadratic, it acts like a quadratic, it can be factored like a quadratic. A quadratic form is AU squared plus BU plus C, where whatever U is, and then this degree is always half of that degree, and then I always have a constant left over, because that's how normal quadratics look. You have a squared and then a x to the first. 1 is half of 2. That's what a quadratic normally looks like. This looks like a quadratic because my middle term is exactly half the degree of my leading term. And I got a constant at the end. If this was x squared minus 3x minus 4, how would you factor it? Okay? So what do you think is going to be different because of this? Because x times x does not make x to the fourth. But they're squareds. That's it. That's the difference. If you're not sure, FOIL that out. I'd get x to the fourth plus x squared minus 4x squared minus 4. It's still going to get me the same thing. Okay? So this is quadratic form. It's like a quadratic. I can treat it like a quadratic. Turns out it wasn't a quadratic. But now I can solve this no problem. I can either do difference of squares, x plus 2, x minus 2. Sum of squares, x plus I, x minus I. Because the square root of a negative 1 is going to give me I. Or maybe I say x squared minus 4 equals 0. Like that. 2. X squared plus 1 is 0. So x squared is negative 1, so x is plus or minus I. I don't care how you solve once you get here. But you're not going to get there if you don't know this new quadratic form thing. If it looks like a quadratic, I can treat it like a quadratic. Okay. I'm going to back all the way up to that blue thing, and I'm going to show you what I mean about this quadratic form. If this had been x to the sixth minus 3x to the third minus 4, that is still quadratic form. I would just call it x to the third minus 4, x to the third plus 1. And now that I know what the sum and difference of cubes are, this would be disgusting. Because now that's x minus the cube root of 4, x squared plus cube root of 4x plus the cube root of 16. Now we're starting to get into some pretty heavy stuff. But do you see how it would factor from there to there? Okay? That's all I care about. Each of these has a little bit different flavor. Try them all. Mathematical Baskin Robbins. Get a sample of each.
Eventually. And then I use whatever.
For what? Oh, my parents like this like that.
Not by 4, fourth root.
Just a question. 50 seconds. So I put 1 right here for my formula, right?
What formula?
Quadratic.
Oh, okay.
So plus or minus square root of.
Whoa, back up. These are not cubes.
No, they're.
So you can't do.
So I have to do this one.
You can't do sum of cubes if they're not cubes.
So is it not x squared minus 4x squared plus 4?
Yes.
It is?
Yes.
Oh, okay.
It's quadratic form again. Right? Treat it like a quadratic. If that said x squared minus 16, you would have said x plus 4, x minus 4. The difference is,
They're both squared because it's a.
and now this is also difference of squares. So keep going. Sum of squares, keep going. Or set them equal to 0 and square root. Okay. Back here. We did the square root of this guy to get this. We did the square root of this guy to get that.
So I have to square root the 4 now?
Uh-huh.
And the 2?
And the x squared.
So it's just. So then it's going to be a big old. Like x plus 2. Like that. And x plus 2.
Minus.
Minus.
Remember conjugates.
Oh,
Because they make a plus minus pair. Now this one is x plus 2, x minus 2. Because this one is sum of squares, you're going to have x plus 2i.
Oh. Alright, I get that now.
And just so we don't get confused later in our notes, I'm just going to do this so you know which one goes with which. And then set each of those 4 equal to 0. Right, we're right in the meat and potatoes of math right now. This is.
Are we allowed to do that?
Are we allowed to?
Solve with quadratic like this one. Here.
Not until you take out the x.
Yeah, like but then GCF, but then you can solve by the quadratic.
Yeah.
Oh.
Well, it's a quadratic. I don't care how you solve it.
Okay. That's easy enough then. 2x.
But last I checked, that was factorable. Well, factors of -8 add up to 2. Hi. Okay. Now, unfortunately, these are to the 4th. They're not cubes. You can't use the cube formula on something to the 4th. But what you can do is treat it like quadratic form. If this was x squared minus 16, you would say x plus 4, x minus 4. Difference of squares. The only difference, because that's a 4, is these are going to be squared. Because the square root of x to the 4th is x squared. Now do the same thing again to those. This is a difference of squares, just like this was. So it's x minus square root 2, x plus 2. This is a sum of squares, so it's going to do the same thing. There's just going to be i's at the end. So still x minus 2, x plus 2. If you don't like that, which the nod until it's over is telling me, set them equal to 0. X squared minus 4 equals 0. So x squared is 4 square root. Better? Same thing here. X squared plus 4 equals 0. So x squared is subtracted over, negative 4. Square root both sides, plus or minus 2i. So you can factor it or square root it, whatever your jam is. Here I would take out a GCF of an x first. Alright. Chatter says we're either done or not willing to go further. Yo. That is the difference of squares. What's the square root of 16? What's the square root of x to the fourth? So x squared plus 4, x squared minus 4. Difference of squares.
I'm confused. I'm not. Okay, so what's 16 squared? Or something like that, and x to the 4th squared.
Oh, okay, I see. Yeah,
Wait, I see you got work.
Difference of squares. Nah. It's also written on the chart that we just bypassed.
And the problem with
What we need to be aware of, though, is if I ever have sum of squares, it just means when I try to square root, it'll be a square root of a negative. So it's a plus bi, a minus bi. Okay? Which is right there. Right there. Difference of squares. There we go.
Sí, muy bien.
Okay. Now I'm going to do that again. Sum of squares. What's the square root of x squared?
X to the fourth.
No. What's the square root of x squared?
Oh, they said X for
X. Square root of 4. 2. Because it's a sum of squares. X plus 2i. X minus 2i. Difference of squares. Square root of x squared. X. Square root of 4. 2. X plus 2, x minus 2. Set this equal to 0, that equal to 0, this equal to 0, that equal to 0, and get x is a positive and negative 2i, a positive and negative 2. That's doing it by factoring. I can factor and then solve by square roots as well. If I took this and set each part equal to 0, I can solve by square roots as well. I need to be able to do both. Okay? That's where the difference of squares form came from. Is someone solved by square roots and they said, oh, hey, it always does this. So I'm just going to say x plus or minus that thing. Okay? I can solve by square roots after this, or I can solve by factoring with sum and difference of squares. When you get really good, after you've spent enough time with these, I can do the fourth root instead. Understanding that it's going to get me, the fourth root of 16 is 2. So it will give me a plus or minus that as a real and a plus or minus that as an imaginary. But that comes with a lot of experience. Okay, this one, everyone one side. X to the third plus 2x squared minus 8x. Take out a GCF of x. I recognize a factorable quadratic, gonna go for it. Set each equal to 0. So that one's a little bit easier. Contestant 3, before I go doing anything, I should probably put everything on one side in standard form. X to the third, 8x equals 8x plus 8. Everyone to one side. X to the third minus 8. Which should look awful familiar. And difference of cubes.
So,
Now that's x minus 2. Cube root of this and cube root of this are my a and b. X gets squared. X times 2 is 2x. 2 squared is 4. Solve by complete the square or quadratic formula is a negative 1 plus or minus I root of 3 is a 2. But you're going to have to quadratic formula or complete the square on that. Like, that's some heavy-duty stuff. This is also where you're going to see a decent chunk of standardized testing in high school. Okay? We're going to practice it. Lots of practice. Now, I'll hop up on the soapbox again and say, look, if you want a college degree in anything, a certificate, no. And degree, an associate's or higher, you're going to need to do college algebra. It's a general. College algebra is just this again. You have to be able to do this to get the piece of paper that says, look at me, I jumped through the hoops, pay me more. Okay? But in terms of applicability, no. This does some really cool stuff later in math, and you have to know how to do this to get to the cool stuff, to get to the engineering, to get to the physics, to get to all the fun stuff where you get to blow things up. But you're not going to get there if you don't get past this. If you want to charge $65 an hour to repair HVAC, you don't need this. But if you want the degree, you have to jump through the hoop. Okay? So, like, that is the way that our educational structure works in this country. My job is to try to get it really tough stuff down as simple as I can to help get you past that threshold. Like, if you got to jump through the flaming hoop to get the piece of paper that says pay me more, I'm trying to chuck you through the hoop so that then you can go live your life. Okay? I want us to try just here. This is difference of cubes. Can you do difference of cubes? The formula is right there in front of you. What cubed makes 27x cubed? Close. 3x. What cubed makes 1? Okay. This is the difference of cubes. Go look at the difference of cubes formula. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. This is kind of like the training wheels are off, I'm pushing your bike. This is how you get started. Can you jam this stuff in here and take it all the way to the end with the 3 answers? Go. And yes, as some of you found out, there was a full restock on Pop-Tarts. I have all the flavors. No Food Bar Friday. No Food Bar Friday.
That was the rule. Never had Food on Friday.
No.
Does the cashier ever look at you when you buy something?
No, I go through the self-checkout because I have all the boxes turned upside down in columns in my cart so that I can grab the thing and beep, 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 beep. Yeah, I mean, this is like year 6 of this, so. Yeah, they're pretty good. We got Fruit Loop ones. Okay, I'm pretty sure everyone's got those. Be careful. What is the A?
3x.
So what happens when I square 3x?
3x squared.
No. No. 9x squared. Square the 3 and square the x.
Shoot, darn.
Remember, you are plugging in whatever A is right here. If A is 3x, you have to square all of 3x. And that's kind of a, if you see this, you done screwed up. I see kids do this an awful lot. I don't want you to run into that, so I'm kind of making a big deal out of it right now. There. Okay. Then it's a matter of doing what we've been doing. Set this one equal to 0. We got a lot who want this. Stick in 3, 3, 9, 9, 1. Getting x is negative 3 plus or minus 9 minus 36. What is the square root of negative 27 reduced to? 3 root of 3, I. Right? Because I've got the square root of negative 1 by 9 by 3. That's a 3, that's an I. Okay? Well, then I've got negative 3 over 18 plus minus 3i root of 3 over 18. Now simplify x is 1/3 and a negative 1/6 plus or minus root of 3 over 6i. That bothers me. Okay. This is some pretty heavy stuff to take in. I do not feel confident saying, here, go practice this. No homework. When you come in tomorrow, no daily quiz. We're just going to pick it up with more practice here. Remember, tomorrow is also a short schedule. So we're just going to finish this off and then get the assignment. Yeah, early release, so short schedule. Quiz is still Thursday, yes. Oh.
Hi.